I just discovered a brand new Gemini feature in Google Colab that literally automates the 90,000 a year job that I got straight out of grad school. You just have to upload a dataset, tell it exactly what you're looking to analyze, and then it will do the rest. From planning what to actually do with the data, to cleaning it, to creating visualizations, and even creating predictive models end-to-end, hands-off. When something inevitably goes wrong, it's really good at being able to correct its own mistakes, iterate, all in real time while you watch and observe its entire thought process. That's why in this video, I'm going to show you how you can go from a data set and a single prompt all the way to full data analysis worthy of a junior data scientist in minutes. Let's dive right in. All right, so if you don't know what Google Colab is, it's basically a Google Doc for writing code. But in this case, you don't really have to do anything yourself. You just have to upload the data and write a prompt and watch the feature do its magic. So if we go into Google here and then we just say Google Colab, I'm just gonna send that over. And then we're gonna see this link here, welcome to Google Colab. We'll click on that. And then when this pops up, just create a new notebook. And you're just gonna see now a blank screen with one line. And it will say here, start coding or generate with AI. Now, when I did my master's and my first couple data scientist jobs, I lived in here to be able to prototype and test out ideas. You wouldn't necessarily use Google Colab for production level code, but for tinkering, it's really good. And when it comes to sharing code with you and other members on the team, it's also really helpful as well. So we're gonna spend this video primarily focusing on this Gemini feature at the right-hand side, but just in general, how you would write code here is you'd have some form of label. Let's say you wanna organize your code and say, this is my tic-tac-toe game, right? And after adding the title, you could either start writing code yourself, you could ask Claude or ChatGPT to make it for you, or you could click on generate with AI, and then we could just ask for something like, build me a simple tic-tac-toe game. Okay, and if we send that, Gemini within this actual workbook will generate the code so that all we have to do is run it, and assuming that it works the first time, we'll be able to use it. So if we click play here, it's just gonna load the server. So I'm going to say connecting, and then beyond that, it's going to just start the game if we just wait a second. And now that it's running, all we have to do is just say row number 1, and then column number 2, and there's our X. And then in this case, it's not using the computer to actually create the tic-tac-toe game, but in general, this is how it would work if you wanted to generate code or use it for coding purposes. And like I said before, all we care about is this Gemini feature right here. And all we're going to do is drag and drop or upload a file to Gemini. And in this case, we're going to upload a file called automation. And I'll just open that up right here. And this is a hypothetical data set that I made using Claude. And pretty much this is what it looks like. If we zoom in just a tad, we have some process ID. We have the name of a process. We have the department of that process. How many manual steps it takes, the number of time in minutes it takes. Of the 60 minutes, how much is manual time, the different systems that are used, the hypothetical process owner, and then the frequency of the task, and then the last review date of that task. So I created this hypothetical data set because there's probably tons of information that you could give to an analyst or your AI junior data analyst to be able to look for trends and see what's happening. So if we go back into the data here, I could now ask for the type of analysis I want, and depending on the scope that I'm looking for. So I want you to look through this automation data, and I want you to do a deep dive on all the trends that you see in terms of what are the tasks that we're spending the most time on, who is the owner of certain tasks that take the most time, what are the biggest opportunities for us streamlining automation in the company by taking on high value, high time-intensive tasks. So let's take a look at those and do as deep dive as possible, and then we'll go from there. Now I just freestyled that, and now it's going to transcribe what I said using a little handy tool. So now we have all of this, we attach the file, then we just click send right here, and now it's going to just think. It takes around 10 to 15 seconds, and then we get something like this that says, here's a set of tasks I can execute in your notebook to help you answer this question. You're going to load the data, explore the data, wrangle the data, fancy word for just, if there are errors in the data, it will try to fix them, remove them. If there are nulls or blanks in columns, it'll try to normalize them. And then it's going to analyze it, create data visualization, data analysis, and then finish the task with a summary of insights. So imagine you gave this to junior Mark 5 years ago. I would do the exact same thing here in the exact same process, except this will do it in minutes, and for me it took a couple weeks. So in this case, I will click execute plan, I'll click continue, and then it's going to start executing its plan step by step here. So for the most of this, I will pause the video, but when it's preparing to execute the plan, it's just going through the data set you have. In our case, this data set isn't too large. It's around 100 different rows, so it should be pretty quick. And you can see here, it's loading the data in real time using something called pandas, a library. And then it's going to load the information and just filter on certain components. And what's cool about it is it's going to start seeing what data types exist in this data. So do we have numerical data, what's called categorical data, meaning something like department or process category. And you can see right here, it's analyzing if there's any missing values from columns. So the same thing you'd want your data analyst or data scientist to look at is what are our unique values for each and every column? What is the distribution of our data in the columns that we can measure? Let's say total time spent. And then it's going to start doing some data wrangling, trying to manipulate the data in a way that it can prepare it for analysis in the best way possible. So beyond this, I'm just going to pause till the next parts are done, and we'll go through the rest of the results. So it took around 7 minutes to complete, but by the end of it, we had all of this. So it created a data analysis section where it went through, looked through the data. You'll see here it made some mistake where it was doing analysis on a column. It didn't programmatically target properly. It then reasoned to correct itself, saying the previous command failed due to something called a key error. If you're not development inclined, don't worry about what that is. It then fixes this error to basically structure the time and allocate what it looks like from different processes and categories. If we move on to the data visualization section, you'll see it dives a bit deeper, doing things that, again, I spent a few hours going on the internet back when Stack Overflow, a forum for copy pasting code or sharing bugs and getting people to help you fix them, I would spend a few hours just making these types of visualizations. So you'll see here first, it said the top 10 time-consuming tasks, and then it says IT ticket resolution, HR recruitment, procurement, etc. So that's this section. And if we zoom back out and go back down to the next section, this is the distribution of total time spent by owners. And in this case, Judy takes the cake with the most amount of manual tasks in terms of time spent. And then Ivan, and then you have Heidi, Grace, and a little sidebar. You can tell this is not perfect because if I was the person creating the data visualization, I would know that if you have more than 4 or 5 categories, a pie chart is probably not the best visualization to go with. So this is kind of proof that we're not at quote-unquote AGI yet, but this is definitely a big improvement, and something that out of the box takes minutes is super helpful to just wrap your head around it. And if you keep going, we have average time spent on tasks, average time spent on tasks by process category. We have correlation again of manual steps and total time. And then that pretty much sums up the visualization section. It does some correction on how it actually analyzed it. And beyond that, yeah, I don't think there's anything too crazy there. And when it comes to the data preparation section, here it actually goes the extra mile, where it creates a new column called optimization potential, where it scores how automation worthy this task is, given how much time it takes, the steps it takes, and which category it's in. And if we take a look at the output file, you'll see if you scroll to the very end, we have that column, optimization potential score, and you can see it ranges from 1 to 10, and it's tagging every row with, out of 10, how automation worthy is it, or what is the priority of it out of that specific score. And at the very end, like I said, it gives a summary, the same way a data analyst or a junior data scientist would go do all this analysis and then come back to you with an email or a mini presentation on the results. It says a summary of Q&A, what are the tasks that we're spending the most time on, IT ticket resolution, HR, etc. Who is the owner of certain tasks that take the most time? So it's Judy in this case, and it goes in chronological order, similar to that pie chart that we saw. And then when it comes to key findings, this is what I found to be interesting. It goes through like the so what's, which as a data person and as a data function that's missing from a lot of small businesses that we do consults with, This would be super helpful because this points out some glaring things that just some basic aggregation and summing can really bring to light. So for this one, manual process, this isn't exactly the most golden nugget. It says tasks with a manual process category tend to take more time. No duh. In this case, high potential optimization, HR recruitment and procurement are identified as high value, high intensive tasks with high potential optimization score. And then when it comes to insights, prioritize automation efforts on recruitment and procurement. So it's as if you also had a mini consultant at the end where you have the data analysis, the preparation, the wrangling, and then you have the recommendation based on the analysis at the very end. And again, I used this for free and took 5 to 10 minutes. Is it perfect? Absolutely not. If I were to go through this, there's probably a lot of areas of improvement where I'd put maybe the code into Claude and say, you know what, I want to analyze it in a different way. But just for getting started, this is super useful. Now this is cool, just a demo, but I tried 3 different experiments with other data sets just to show you the types of depth you can get to, because this is not even creating a predictive model or a forecast, but you can do that, and I'll show you right now. All right, and for this forecasting model, I basically created another hypothetical data set you'll see right here. If we pull it up and say forecasting, it's a very simple data set. It's time series. So we have number of leads, number of conversions, the revenue that was generated, as well as the marketing spend. So you can do similar types of analysis. You can do return on marketing spend. You can do conversion analysis, lead to conversion ratio, different ways you can actually cut that data. But what I wanted to test was, could we create a forecast, again, hands off? When it comes to the stats world where I used to come from, you used to use different models to create trends and look for seasonality in data. And this happened to do the exact same thing really well. So if you go here, what I did is I just said for time series analysis, explore trends, seasonality, and potential cyclical patterns in leads, conversions, and revenue. Visualize the time series data to identify anomalies or significant shifts over time. And then I give it some clues as to how it can do that forecasting. In this case, I literally wrote this with ChatGPT. I said, hey, here's some data. I want to do forecasting. Can you tell my AI agent how to actually write or create the forecast analysis? And then it came up with this pretty much. And then if you don't know what this word means, again, GPT said it. It's basically the way you want to evaluate whether your forecasting models are on or off, or if they're doing well or if they're accurate. And then we say provide actionable recommendations for strategy and resource allocation based on the results. It does its plan. We execute the plan. It goes through the whole thing. And we get something like this, where we get the data that's loaded, and then we have data exploration, and we'll zoom in just a tad here. It goes and calculates what's called descriptive stats. So it's trying to see like, what is the average number of leads, the average number of conversions, the average revenue, and then what are the different quartiles of that data. It then starts to generate some visualizations to tell itself or show itself what some underlying trends look like. And then it actually visualizes really well the leads over time, conversions over time, and revenue over time. And then when it comes to the data analysis, this is the section that I was really looking for. It was able to extract things like the trend or whether or not there was seasonality in these actual results over time. And in conversions, it tried to do the same analysis, and then again in revenue. So then it does correlation analysis where it sees, okay, how correlated are leads to conversions and conversions to revenue and revenue to leads. And then it comes up with this conversion matrix. It goes through and it starts creating a summary of the actual analysis it did. So for leads, strong positive correlation with conversions and revenue. Conversions, strong positive correlation with leads and revenue. Again, nothing groundbreaking here because I gave it a very simplistic data set with not too many features to actually analyze. But if we keep going for data prep, it's now preparing the data for the forecasting analysis. And it does all this code that I remember writing manually over days to be able to create a forecast. So if we just scroll down to the bottom here, it makes a couple errors. It fixes those errors right here, fixes the error in the previous code block. And then if we jump to the good stuff, this is where now we have a forecast and it starts evaluating its forecast against what the actual was. So if we keep going down, data analysis, it starts to look at correlation between those different metrics as well. If we go to the conclusions, you'll see here marketing spend impact, a strong positive correlation, 0.85 for conversion, so that's out of 1, so that's very correlated. 0.84 for revenue, also very correlated, exists between marketing spend and both conversions and revenue. Again, if you had more features in this data, that's where you'll get some more insightful results. But this is just to show you a baseline of the types of information you might be able to derive. So that's forecasting. On the data analysis side, I just wanted to push its limits and see how nice the visualizations it could create would look like. So if you go down here, it's pretty standard, but you can see there's a lot of variability. In this case, this data set was a bit more rich. So if we go back to the data set here, this one had age, gender, income, occupation, neighborhood, service request, and all kinds of things here about, again, leads and whether or not they converted. And if we go here, you'll see distribution of age, gender, income, distribution by occupation. It's kind of like reading an actual report from The Economist or something. So you can keep going here. It creates a distribution by neighborhood. And this is all, again, without your guidance. You're not telling it to do this analysis unless you want to. It's just deciding what it should analyze based on what's most important. And as we go down here, it does this really cool thing called, again, a correlation matrix. But because we have more features to analyze, you can start to see this heat map where you can see which features are really correlated to each other. So income is negatively correlated to response time. So those two things are not correlated, which makes sense. Whereas something like, let's say, age and income, obviously, is going to be very correlated. Typically, as you are older, you have more money or more revenue. So if you keep going down here, you'll see some more visualizations, less pretty, but still comprehensive. It takes a stab at doing some trend analysis over time because it sees that we have some date components in there. And then pretty much that's about it. At the very end, I ask it as a next step because what you can do is, I asked it in this chat, can you write some code to use this library called Plotly? Plotly just makes more interactive visualizations. And I copy pasted that code and I was able to get something like this, where I can actually change it to gender and then age. And then if I were to click run, you'd be able to see these actually superimposed. And you can zoom in like you would on a typical dashboard, like Power BI or Tableau or what have you. So beyond what you get out of the box from the code it completes here, you can keep going on in this tab and saying, can you make an interactive dashboard? And you'll see here, it'll give me this code snippets. And then I just copy paste those in the chat itself or the actual canvas itself and then run them. And then I'll get these kinds of results. So very cool on the EDA side. And for my last experiment, I wanted to take on something a bit more complex, where we would actually try and push it to do the old world of AI before generative AI even existed, called machine learning. And in this world, we would take a data set, and let's say we had a list of customers that left our company. We would be able to take that list, and if we had enough data, typically not tens of rows or hundreds of rows, but more so thousands and ideally tens of thousands of rows, we'd be able to create a model to help us input new customer information. And based on prior performance, we'd create a model that could predict whether or not this person would leave or not. So I created yet another hypothetical data set here that I called customer churn dataset. If I pull this one up and I zoom in a bit right here, we have sign up date, we have age, gender, monthly spend, 10-year months, the type of payment method they had, contract type, support calls, logins per month, which is actually a really important metric in general, and then whether or not they churned. This is super important because when it comes to machine learning, you need what's called a target, which is you need a column that you predict on, yes or no, whether or not someone will leave the company or leave your business as a customer. So in this case, we have that list, and I generated around, I think, 1,000 different rows. Yeah, 2,000 different rows here, which is, again, not ideal for a machine learning model. And the reason why is if you train on a very small data set, it begins to memorize that trend versus really understand it. Before, again, we had these generative AI stuff and we could fine tune LLMs. So it leads to results that work really well in testing, but when it goes out in the field, it's really inaccurate. But again, just for the purposes of this demo, what I asked for was using this customer churn data with a data set of 2,000 rows, such as customer ID, sign up date, age, gender, monthly spend, etc. Please develop a comprehensive script that builds a predictive model. Now, I'm sure you can tell I didn't actually write this or even say this. I again uploaded the dataset to Claude, asked it to make a prompt for my AI agent that's a data analyst, and I just copy pasted it here. We uploaded the dataset, it made its plan once again. In this case, it's a longer plan because to do machine learning, it's not just about planning, it's about wrangling the data and structuring and transforming it in a way where you can actually do this type of predictive analysis. And then it executes this entire plan. And you'll see here, anytime you see this little clock icon, it means it repeated because it encountered its own errors. And then if we go through the results, we won't over-index on anything we've seen before. It creates and cleans some new features. It explores the data. Again, it creates trends to see, engage what's happening with the distribution of age, tenure months, support calls, logins per month. It makes some more box plots here to analyze the data, does those little matrices. And then as we go down, let's go to this part here. So here's where we do the splitting of the information, because typically in machine learning, you want to have a set where you train on, which is typically 80% of the data you provide. And then you have a 20% you leave on the side where you basically just use that to see what are the results of the model on data it's never seen before. So testing on unseen data. And if you go down to the very bottom, it's good enough to even evaluate its prior results. So if we scroll down here, it starts to gauge its accuracy. And there's some other metrics in machine learning that tell you how well the actual algorithm did. And then in terms of evaluation, it creates this matrix to also convey performance in different realms. I won't over-index on that because, again, you might not care. In terms of this final graph here, this is typically a really important graph you do to basically say, based on this algorithm, what are the most important metrics or the most important fields that make it tick, that are very correlated with the results it outputs. So in this case, interestingly, from this data set, it says that the payment method of PayPal is very influential as to whether or not this customer ended up churning. And then there's some other payment methods that you'll see, but this tells me that payment method is somehow correlated to a customer leaving. So whether payment method or not is a proxy for the quality of the customer, where the customer is coming from, I don't know. This is all fake data, but then you can see its gender, support calls, contract months, etc. And again, if you don't care for the machine learning part and all these little nitty-gritty stuff, you could just ask it to do the predictive model and just gauge what it finds as results and just use that to help your business acumen or your instincts, especially if you don't have the capacity or the budget to hire your own mini junior data analyst or data scientist. This is a great way to be able to tinker with data, bring it to life, and actually do things with it, like forecasts and predictive models, and see how those tick. If this is how this works in 2025, I can only imagine what 2026, 7, 8, and 2030 looks like. I can imagine a world where you can go from a data set to very high quality Tableau, Power BI, Looker-esque dashboards end to end, all just by a very basic prompt as to what you're looking for. If you want to tinker with any of the data sets I put together or the workbooks that I showed you, I'll make all of them available in the description below so you can go in, see how I prompted them and how I went through that process and how it actually executed that workflow. And if you like this and you found it interesting, let me know down in the comments below. Helps the video, helps the channel. And if you are a business owner, business leader, or CEO that wants to see this and this kind of exclusive content more ahead of time before I even release it on YouTube, check the second link in the description below and maybe I'll see you there. I'll see you in the next one.